Hello students, welcome to Educate. We are going to continue with chapter 3 of class 12 physics. Today we will do numericals. In previous lecture we have done the concepts of EMF of cells, combination of cells, KCL, KVL and Wheatstone bridge, and I think you must have watched that video. And now let's start from first question. So first question says, the storage battery of a car has an EMF of 12 volt. If the internal resistance of the battery is 0.4 ohm, what is the maximum current can be drawn from the battery? So I maximum is to be found. So whatever EMF of cell has, that must be divided by R internal. Means if you divide the EMF of a cell by its internal resistance, you will get I maximum. So in this case, it is 12 divided by 0.4. So you can do one thing, you multiply by 10, multiply by 10. So this will become 120 divided by 4, and that is 30 ampere. So it is very simple question. You can easily do. Now consider second question. A battery of EMF 10 volt and internal resistance 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, what is the resistance of the resistor? What is the terminal voltage of the battery when the circuit is closed? Question is simple, and you remember very well the expression that we write E equal to I times small r plus capital R. In our question, here EMF is given as 10, I is given as 0.5, internal resistance is given as 3, and external resistance is to be found. So it is simple. If you divide by it, so you will get 0.5 equal to 3 plus R. From where? This will become 20. So 20 equal to 3 plus R. From where you will get R equal to 70 ohm. I think it is clear. Then they are saying what is terminal voltage. If you remember, when we expand it, we get IR plus IR, and this portion is called terminal voltage because condition is there. What is the terminal voltage of the battery when the circuit is closed? If circuit is not closed, then terminal voltage will be equal to EMF of the cell. But here circuit is closed, so I times R. So we have I as 0. So terminal voltage will be equal to 0.5 times its resistance 17. So this will become how much? That will become 8.5 volt. I think you have understood. There is next question. Next question says, at room temperature 27 degrees centigrade, the resistance of a heating element is 100 ohm. So condition is given. Let's write it. So temperature is given 27 degrees centigrade initially, T equal to 27 degrees centigrade, and resistance at that time is given R27, say we denote it as 100 ohm. And then what is the temperature of the element if the resistance is found to 117? Now at RT it is 117, and here if we take it as T1, we write it as T2, that will T2 will be better. T2, either you can write it as T. So RT is 117, and here alpha is also given. Alpha is given as 1.7 into 10 power minus 4. So you can do one thing. You can write the relation for alpha and then evaluate. So if you evaluate, what do you get? think, then I will tell. Take 1 minute. Relation, if you remember, I told you R equal to R0 1 plus alpha t. So here you can simplify, you just write R1 equal to R0 times 1 plus alpha t1, and you can take R2 equal to R0 1 plus alpha t2, and then you can subtract the two relations. So if you subtract, suppose you write R2 minus R1, what do you get? So here, if you open the bracket, it will become R0 plus R0 alpha T1, and this will become R0 plus R0 alpha T2. So if you subtract, these two terms will cancel out, and you are subtracting. So R0 will R0 alpha and then T2 minus T1. Here, what is our concern? Our concern is this T is to be found. So we can write here T, and this we write as 27, and here resistance. Here we are subtracting. So R0 is given. If R0 is not given, then we can evaluate it. So other way around we can go. It's not tough question at all. Don't worry. It does not mean that it is tough. So we can do one thing. We can easily calculate other way around. So other way around is like this. You just write the first value 100 equal to R0. R0 is to be found, suppose. And then 1 plus alpha is given. So alpha is this much, 1.7 into 10 to the power minus 4, and times temperature is given as 27. And from here you can get the value of R0. So 100 divided by this much. 1 plus, I'm not evaluating that, that is for you, into 10 power minus 4. So this is R0. Now for second, what do you do? Just write that resistance R, here value is given. So it is 117. So write here 117 equal to R0, this value 100 divided by, you can use calculator for this, 1.7 into 27 into 10 power minus 4, and this is R0 into 1 plus alpha t again. So 1 plus alpha, alpha is same value, 1.7 into 10 to the power minus 4 into g, and then you can evaluate. So if you evaluate it, it will be around 1000, and how much? It will be around 1027 degree. So you can do that. Another way around also it can be solved. So it involves just a calculation. There is nothing more complicated. So let's take next question. Here next question is, a negligibly small current is passed through a wire of length 15 meter and uniform cross section, and its resistance is measured to be this much. What is the resistivity of the material at temperature of experiment? This is question based on resistance. You know resistance R equal to rho L upon A. OL, L is length of wire, rho is resistivity, A is area of cross section. Here our concern is to get a rho, so RA divided by L. Rho equal to RA divided by L. We can put the values. So R is given as 5 ohm, and area of cross section as 6 into 10 to the power minus 7 divided by length is given as 15 meter, and just evaluate it. So here it can be cancelled. It is G, 5 3 3 2 like this. Ohm meter, unit will be ohm meter. So this question was simple. Okay. A silver wire has resistance of 2.5 ohm at 27.5 degrees centigrade and a resistance of 2.7 ohm at 100 degrees centigrade. Determine the temperature coefficient. This time we have to find out the value of alpha. So basic formula I am writing, then take 1 minute to consider what to do. R equal to R0 1 plus alpha T. This is basic formula. Now think and try. Here question is simple. What you can do? Just write the two resistances. 2.1 ohm at 27.5 degrees. So just write 2.7 equal to, keep R0 as it is, 1 plus alpha into 27.5, and second equation you can write and then divide the two. This is first equation. Then second one is I think I am not correct here. At 27 degree it is 2.1, so just to make it 2.1, so 2.1 equal to R0 this, and then 2.7 equal to R0 into 1 plus alpha into 100. Equation number 2. Correct? I think you have understood. And now if you divide, what is it? 2.1 divided by 2.7 equal to 1 plus alpha into 27.5 divided by 1 plus alpha into 100. Now make cross multiplication and simplify to get alpha. Just do calculation and then turn. So you will get 4.4 into 10 to the power minus 3 and per degree centigrade. Per degree centigrade. Per degree C. Correct? I think you have understood. Now, next question is, a heating element using nichrome connected to 230 volt supply draws an initial current of 3.2 ampere, which settles after few seconds to a steady value of 2.8 ampere. What is the steady temperature? If room temperature is 27 degrees centigrade and resistance coefficient is 1.7. This is same question. So again, it involves only calculation. So first of all, you have to find out the resistance. What is R1, what is R2. So first case is 230 divided by 3.2 ampere current. And this is 230 divided by 2.8 ampere current. Just evaluate using calculator. What do you get? First case 71.875, and what will be the second one? It will be 82.143. 82.143. Now other informations are given here. Temperature coefficient is also given. So again you can apply the same formula, that R2 equal to R0 times 1 plus alpha into first temperature. In this case it is 27 degree, so just write 27. And the second case this for R1 you can take this, so R1 equal to and for so R1 has value this 71.875, and for second write 82.14, sorry, equal to R0, and 1 plus alpha. Alpha is given, alpha we will put alpha times t, and we can put the value of alpha. We can divide the two equations, and then we can put the value of alpha, and it is a little complicated only in terms of calculation, so you can do that. To get the answer, use calculator. And if you evaluate, t will come out to be 867.25 degrees centigrade almost. So calculation is simple. Now let's consider next question. Determine the current in each branch Determine the current in each branch of the network shown in the figure. Again, you have to apply, sorry, KVL. So when we apply KVL, let's draw the diagram here. This is 10 ohm, then here this is 5 ohm, then this is 5 ohm, here this is also 5 ohm, and what about this? This is 10 ohm, and then it is connected through 10 ohm resistor here, and then there is a battery of 10 volt, right? Now, in this case, you can assume that current I enters here. Say this is I1 and say this is I2. At this point, say it is I3, then I1 minus I3 will pass through this resistor 5 ohm. Now see the situation here. This is I3 and this is I2. So the two will combine here. So I2 plus I3. Now we have various loops. First loop, second loop, third loop. So we are going to write the equations of 3 loops. So if you consider loop number 1, so what is happening? 10 times I1, then here, plus 5 times I3, this, then minus 5 times I2 equal to 0. This is first loop. You are moving in the direction of current. Here you are moving against the current. That is why negative sign. This is equation number 1. You can simplify it either by dividing by 5 each term. Okay. Now consider second loop. So we move like this. In this direction we move. Then what happens? So here we will move in the direction of current. So we can say I1 minus I3 times 5 is okay. But here we are moving against the current. So we will write I2 plus I3 times resistance is 10. Here also we are going against the current. So minus 5 times I3 equal to 0. We can simplify this equation also. This is second and this is first. Now we consider this loop, third loop, which is like this, from this side, and this side, and this side. So our motion will be like this, right? So here we are reaching to the positive terminal of battery. So here we will write 10 equals, then this resistance, here current is I. Also one equation can be found here. I is here at this point we can apply that KCL. So I will be equal to I1 plus I2. This is another equation. Say this is third one. And then we are taking this loop. So 10 equal to 10 times I, not I1, 10 times I, because this is I, 10 I, Then we enter like this, so 5I2, and then we go like this. So we are moving in the direction of current, so 10 times this I2 plus I3. We simplify, and this is equation number 4. Now we have 4 equations, 3 variables, so we can easily solve. So I think you have understood the circuit analysis, and rest is your work, you can do. Now we are going to see other questions. Next question is, there is a storage battery of 8 volt and internal resistance is 0.5 ohm is being charged by 120 volt supply using a series resistor of 15.5 ohm. So here, as I told you, this is reverse case. First of all, it is being charged by 120, and positive of cell is connected to positive of the source. So net voltage will be 112 volt. You understood? This is suppose charging point whose voltage is 120, and here 8 volt is being connected. So net voltage will be 120 minus 8, that is 112 volt. Now we can find the current. So what current is flowing? So 112 volt is total resistance, sorry, total voltage, and total resistance is 0.5 and series is 15 point. So this will be 16, 15.5 plus 0.5, 16. So 7 ampere current will flow. There is no problem up to here. Now equation, as I told you, E equal to IR plus VR will no longer be valid while charging. Reverse case will be there. It will be equal to, not VR, this is IR. So which is also written as E equal to IR plus V. But as I told you, in case of charging, there will be reverse case. So V will be E plus IR. So in our question, it is asked that what is the terminal voltage. So terminal voltage will be 8 plus I 7 ampere, internal resistance 0.5. So 3.5. So 8 plus 3.5, that is 11.5 volt. And there is one more question, that there is a series resistor. What purpose does it serve? Here 15.5 ohm resistor is used. If there will not be series resistor, in that case current will have very high value, so it will damage the circuit. So that is why series resistor is necessary to control the current. Now let's do next question. In this question, certain information is given, and let's see what is given and what is to be found. Question says the number density of free electrons. It means value of n is given. N is given as 8.5 into 10 to the power 28 per meter cube. Okay. And how long does an electron take to drift from one end of 3 meter wire? Here there is 3 meter wire. If we find drift velocity, so we can get time, distance upon speed, Vd. So time is to be found. This is our main concern. But whether drift velocity is given or not. So to get drift velocity, let's consider other information given in the question. How long does an electron take to drift from this much? And the area of cross section A is given 2 into 10 to the power minus 6 meters square. That is okay. And I is also given 3 ampere. What is formula for drift velocity? I is given by N, E, A and Vd. If you remember, N is number density, E is electronic charge, A is area of cross section, and Vd is drift velocity. And our concern is to get drift velocity. Other informations are given in our question. Here is I given. So yeah, I is given 3 and the density is given 8.5 into 10 to the power 28. So I equal this, and electronic charge 1.6 into 10 to the power minus 19 times area of cross section into 10 to the power minus 6 times Vd. Now try to evaluate for Vd what you are getting. So 3 divided by, here consider these powers. Numbers are 8.5 into 1.6 into 2. But what about powers? So power is here 28 and this is 25. So 3 power positive will be left. It is going in denominator. So here it will be 10 power minus 3. I think thing is clear. Now positive power, so it will go in denominator and then we write it. So this 3 into 10 power minus 3 and then okay. Now evaluate it. Take 1 minute to get the value of Vd. So it will be around 1.1 into 10 power minus 4 meter per second. So you have got the value of T, sorry, value of Vd. Now what is left to find T? So 3 divided by this much, 1.1 into 10 to the power minus 4. Now further evaluate. This will become 3 followed by 4 zeros divided by 1.1 or 3 followed by 5 zeros divided by 11. Now just evaluate how many seconds you are getting. It will be 2.73 into 10 power 4 seconds. It's too large. It means it will take hours. So how many hours? More than 7 hours. 7.57 hours, like this. So I think you must have enjoyed the lesson, and all questions we have done. Thank you for watching. Team Educate.